good evening, whatever you feel connected. Today we are going to discuss a new chapter of class 9th physics, which is motion. So basically, what is motion? The movement of a body or object is called motion. Generally, we can say that a tree is fixed at a place, so we say that it is stationary. Similarly, a house, a school, a factory, electric poles, all are stationary objects which remains fixed at a place. On the other hand, a man, animals, birds, car, buses, trains do not remain stationary all the time. They can move from one place to another. For example, a man moves when he walks along a road. A bird moves when it flies in the sky. So the general definition of motion is a body is said to be in motion when its position changes continuously with respect to a stationary object, which is known as reference point. For example, when the position of a car changes continuously with respect to stationary object like houses and trees, we say that the car is moving or that the car is in motion. So basically हम कह सकते हैं कि जो आपका मोशन है, मोशन a body is said to be in motion. That means आपकी जो बॉडी है वो मोशन में कहलाएगी कब, जब उसकी पोजीशन टाइम के रिस्पेक्ट में आपकी चेंज हो रही है. So in this figure we can see that planet is revolving around the sun. That means sun is stationary for planet and now an object is said to be at rest when its position does not change with time. अगर आपकी बॉडी की जो पोजीशन है वो टाइम के रिस्पेक्ट में चेंज नहीं हो रही है, दैट मीन्स वो आप ऑब्जेक्ट के आपका रेस्ट पे है. फॉर एग्जांपल, बुक इज एट रेस्ट ऑन द टेबल. सपोज आपने कोई बुक को रखा है टेबल पे, तो क्या आपकी रेस्ट है क्योंकि उसकी पोजीशन आपकी चेंज नहीं हो रही है. नेक्स्ट, एन ऑब्जेक्ट मे अपीयर टू बी मूविंग फॉर वन पर्सन एंड स्टेशनरी फॉर सम अदर. लेट अस टेक एन एग्जांपल. सपोज एक आदमी आपका बस स्टॉप पे खड़ा है और उसके अपोजिट डायरेक्शन में एक पेड़ है और सेम उसी डायरेक्शन से आपका एक मूविंग बस भी उसकी तरफ आ रही है. इन दिस केस हम कह सकते हैं आदमी के लिए पेड़ रेस्ट की पोजीशन पे है, बट जो आपकी बस है वो मूव कर रही है, दैट मीन्स उसके लिए वो क्या होगी, मूविंग ऑब्जेक्ट हो गया. वहीं दूसरी ओर देखें हम तो जो बस में आपके पैसेंजर्स है उनके लिए जो ट्री है वो बैकवर्ड डायरेक्शन में मोशन कर रहा है, दैट मीन्स उनके लिए ट्री क्या हो गया, इन मोशन कंडीशन. Let us take another example. School is 2 kilometers north of the railway station. That means railway station is our reference point. In order to study the motion of bodies, we should first know the meanings of two terms. First is distance and another is displacement. So basically, what is distance? As we know, in everyday languages, the word distance and displacement are used in the same sense. But in physics, these two words have different meanings. Let us understand this difference by taking an example. Suppose a person moves through C and B and reaches A. He again moves back along the same path and reaches C through B. So we can see that the man starting his journey from 0 to A and then return back to point C. So the distance traveled by a person is total path length. That means OA plus AC, and the length of OA is equal to 60 and length of AC is equal to 35. So the path length is total 95 kilometers. This is the distance covered by the person. Now in the case of displacement, we will consider only initial and final position of a person. The initial position is 0 and final position of is kilometer. Hence the total displacement is 25 kilometer to right. That means displacement is the shortest distance between two consecutive points. The common difference between distance and displacement is the distance traveled by a body is the actual length of path covered by a moving body of the direction in which the body travels, and displacement of the body is always represented by the shortest distance between the initial and final position of the body. When a body moves from one position to another, the shortest distance between the initial position and final position of the body, along with direction, is known as its displacement. That means displacement has magnitude as well as direction, whereas distance has only magnitude, not direction. A physical quantity having only magnitude is known as a scalar quantity. A scalar quantity has no direction. On the other hand, a physical quantity having magnitude as well as direction is known as a vector quantity. The distance traveled by a moving body cannot be zero, but the final displacement of a moving body can be zero. That means distance is always positive quantity. But in the case of zero displacement, how is it possible? The simple answer is the displacement of a moving body will be zero if after traveling a certain distance the moving body finally come back to its starting position. That's it. Hence the initial and final position are same, so the net displacement is zero. Let us take another example. A person moves from O to A, that means origin to A. Total distance is 60 kilometer and displacement is also 60 kilometer. And next is a person moves from O to A and back to B. So the total distance traveled by a person is 60 plus 25 is equal to 85 kilometer, and the displacement is the shortest distance between two points, that means O and B, which is 35 kilometer to right. Another example is a person moves from O to A and back to O. That means total distance traveled by person is equal to 60 plus 60 is equal to 120 kilometers, because the initial and final position are same. The next topic is uniform motion and non-uniform motion. Uniform motion. If an object covers equal distances in equal intervals of time, then the motion is called uniform motion. Suppose a ball rolling on a surface and covers equal distance in equal interval of times, and ball distance travel in each second is equal to 5 meter. So the distance travel in total 6 seconds is equal to 30 meters. So a body has a uniform motion if it travels equal distances in equal interval of times, no matter how small these time intervals may be. So now come to the next topic, non-uniform motion. If an object covers unequal distances in equal intervals of time, then the motion is called non-uniform motion. In this figure you can see that the distance traveled in first second is equal to 1 meter, distance traveled in second is 3 meters, distance traveled in third second is equal to 6 meter, and distance traveled in 4 second is equal to 12 meters. That means this is non-uniform motion. Let us take another example. Two persons A and B started his journey from initial position O at time 9:30 am. Distance traveled by object A is 10 meter and distance traveled by object B in 12 meter, and 9:45 am distance traveled by object A is 20 meter and distance traveled by object B is 19 meter. That means object A travels equal distances in equal interval of time and B travels unequal distances in equal interval of time. Now come to next topic. The motion of a body can be described by three terms: speed, velocity, and acceleration. First is speed. What is speed? If a car is running slow, we say that its speed is low, and if a car is running fast, then we say that its speed is high. That means the speed of a body gives us an idea of how slow or fast that body is moving. So the speed of a body is the distance traveled by it per unit time. SI unit of speed is meter per second and other units is centimeter per second and kilometer per hour. Speed is also a scalar quantity. Now the next is average speed. total distance traveled by the object in total time taken. Suppose a car travels 100 km in 2 hours. That means average speed is equal to total distance traveled by total time taken. That means 100 upon 2 hours, that is equal to 15 km per hour. Next question is, an object travels 16 meter in 4 seconds and then another 16 meter in 2 seconds. What is the average speed of the object? That means object travels first 4 seconds in 16 meter and another 16 meter in 2 seconds. Average speed is equal to total distance traveled upon total time taken. That means 16 plus 16 divided by 4 plus 2, that is equal to 32 upon 6 meter per second. Next question, you can also try this.